Yeah, in an unlikely event, if you, as they say, if you get ballerina questions, you can also shoot at me. But today, in this session, let's focus on like a conversation between platform engineers and a developers of a company, like this imaginary company, right? I'm sure you are smart enough to understand the words that are there, right? So what they want to do is actually build a platform. They want to help their developers. They have a special connection with their development team, right? So they want to build a platform so that they can help their developers. They can make their developers' lives easy. So now developers are curious, like, what is this platform? What does it do? And the engineers say, it's an internal platform. It's exclusively for you. We are not sharing with anyone else, right? So, but still curious, like, what does it do? It's for you. It's called IDP. It's a new buzzword, right? So it's like, we want you to focus on what you do best. You write code, you design your system, focus on the application architecture, right? We'll take care of everything else. You commit code. So now, the platform engineers, now they're curious, and also they want to know, like, how you do software engineering. Because they are platform engineers, you have developers. Developers focus on engineering a solution. Now, before you develop a platform, engineers want to know, developers, platform engineers, they want to know how you engineer a solution. So let's start with a simple example, right? So the developers say, we have an application. Let's take a simple application, right? This could be when you design, when you implement, or even the deployment view, right? OK, we have application. We have organization boundary. Now, the next step, I want to expose my API outside of the boundary. Like, that's a simple requirement, right? So we are using this telecom notation here, northbound communication. And my application is not a single binary. It has multiple components, right? This is usually what we do right now using microservices. We break it up into multiple binaries. And some of these components, we need to talk to external services, right? This is also pretty common. We need to allow that. All right. So this is just one application. If it works for one, it has to work for two. It has to work for three, right? So there are now, imagine this is how you design and implement, and also deployment view. If this is in a single cluster, now we should be able to allow, connect or talk to these components, right? So how do you do that? These are three applications, right? This is a design view. These components talk to each other. And sometimes you want to make sure that you don't cross boundaries. How do you do that? You think about imaginary boundaries around your applications. I'm sure you're familiar with this notation. There was a question earlier as well, the hexagon and octagon, right? So now the developers say, we need a boundary. We need a boundary around my application. I want to make sure my applications stay in the lane. I don't want to allow my team to cross boundaries at the design time, at the implementation time, and as well at the deployment time. So this is my design diagram. And also, how can I make sure that this picture stays the same in the deployment view, right? So the developers are explaining this situation to their platform engineers. So the next picture is kind of abstract view. It says, OK, I have three applications. Let's call it, for now, app A, app B, and app C. App C being the primary one, right? So cell, I'm using the word cell here. So cell A says, OK, we need to talk to primary cell. Primary cell says, we need to talk to cell B. Now, these are all telecom terms like westbound communication, eastbound communication, right? How do you make sure this happens? How do you ensure that this design stays same at the development time? I think Lakmal will talk about the API gateways. So we have a concept called internal API gateways, external API gateways, ingress and egress. So you need to have all these to have control at the deployment time, right? Now, this is just a prod environment. But the developers say, this is one environment, but I need multiple environments here. So this is just software engineering aspect. If I go back a step, this is just a software engineering. Like, how do you organize my applications into multiple domains, right? And then, now platform engineers, now they talk about, OK, we know the next. We know how to deliver. We know how to operate. Like, we know how to observe. Now, the next step is software delivery and operations. Right? So you have code, right? And then what do? When you make a commit, your CI pipeline picks it up, and it will build, it will test, it will push the image to a registry. And then if you are using like a GitOps, well, it will update your Kubernetes manifest, deployment YAMLs, things like that. And then your CD pipeline kicks in, and it will take it to deploy environments, right? So the CD pipelines will first deploy things into dev environment. And then the other pipelines will kick, and then it will go to production. So this is kind of very abstract, very high-level view of a system that they want to build. This system is not enough because you need security, you need to have access control, RBAC for each environment. You know, developers, they have full control over the dev, but they don't have full control over prod. So you need to make sure you have right access for each environment. Then you need, I think Lakmal will talk about it, observability. You need to see what's going on. I need logs, I need metrics, I need traces. If something goes wrong, for developers, we need access to this information, right? Obviously, next one is analytics. And then the important thing is about a portal. Like, we need a UI. We need some kind of way to figure out what are the things that are running in my platform, like a catalog, services, APIs, documentation. You need to have everything. So what we've been talking about is about like delivery operations, software delivery and operations, and the other thing is enterprise software engineering. So these are the two things that this picture shows. So we call this as an IDP. So now the challenge is, now they have sort of an understanding, right? They know what they need to build. These guys, platform engineers and developers, so they know what they need to build. Now, platform engineers are under pressure. Right? So now they are nervous, and they are thinking, OK, we know what we need to build. Now, how should we go about it? Should we build one from the beginning? Or should we buy one? What are my choices? If you have like engineering effort, time, resources, you can build one. And if you have experience, right? Of course. The other choice is you can buy one. You can buy a SaaS offering. Right? That's what we've been talking about. I know you can guess what I'm about to tell. You can build. That is a sensible option. Or you can buy one. Right? That is Choreo SaaS. I'm using WSO2Con SaaS for a reason in this talk. So I think Lakmal also showed this picture. It's a much more complicated version of what I showed. This has more details. It shows various components, various data planes, clouds, and things like that. So this is a very high-level architecture of Choreo, right? To build that, we had to use a lot of open source technologies. These are just CNCF projects. But not only CNCF, we also use a lot of other Apache projects, lots of open source projects. So, and also it took like 300, give or take, person years, right? This can vary, but you get the idea, right? You need experience, you need a team, and you need time to get to this level, right? So now, if I take a step back, if you look at WSO2 history, we are an open source company. That's our core value, right? We start as open source project. All our projects are open source. ESB, Ballerina, API management, identity server, everything is open source. So now we have this beautiful SaaS platform, and also that is private. That's in our private enterprise Git repo. But our value is open source. So what do? We also want to contribute what we learned, what we use back to the community, right? So we have Choreo SaaS, we have open source. So the idea is we want to open source Choreo, but it's not simple. We can't just get the code from our enterprise repo and put it to open source repo. That's not how it works. We have a lot of internal dependencies. The architecture has evolved over the years, right? So it's not an easy task. So if I take a little bit of time on OpenChoreo, the idea is what we have learned over the years, beautiful, best things about Choreo, how do we bring them to the community? That's the idea, right? So how do we do that? It takes time. We just released the 0.10 version like a few weeks ago, right? But we will get the feature parity with the current SaaS version soon. It'll take time, but we can get there. And it'll be a new architecture, like Kubernetes-native, GitOps-friendly architecture, right? And also, it's completely written in Go. I think you guessed, right? We had a BOF yesterday. We talked about, like, hello, Go, goodbye, Java. There are a lot of interesting comments yesterday about that title itself, but that's why our future is going to be written in Go mostly, and Ballerina, and Node and TypeScript for UIs, right? OK. So let's talk about the Kubernetes-native architecture. What do we mean by that? I'll have some diagrams, but I think this is something you have already seen. It's very clear. We know what Kubernetes does. It abstracts away underlying infrastructure from you. You have multiple nodes, right? It gives you a single abstraction for writing applications for both platform engineers and for both developers. Now, how does Choreo fit in? So Choreo is like another layer on top of Kubernetes, right? So what makes this special is, now platform engineers, they can configure Choreo, and they also can go under the hood Kubernetes to figure out what's going on. So they have full access. But developers, they work on top of Choreo. That's the plan. So we hide infrastructure from them so they can focus on what they do. The next slide is a bit about how we map Choreo abstractions to Kubernetes abstractions. All right. So this is like a control plane and data plane separation that we see in Choreo. If you stay within the control plane, the circles or the ellipses that you see are the abstractions that you would work with. There's something called data plane, and that maps to a Kubernetes cluster. You can also have multiple clusters, right? Then as a platform engineer, the first thing you would do is you create a pipeline, you define environments like dev, staging, prod, right? And then let's see how they map to, in OpenChoreo, let's see how they map to Kubernetes cluster. I think you heard about projects, components, right? When you create a project, it maps to a namespace in OpenChoreo. For example, it's not single namespace, it's multiple namespaces. For each project and environment combination, we create a namespace. And when you create a component, now you see that component in in all these namespaces. Right? Another component, the same story. So this is typical Kubernetes. We're not changing anything. These are Choreo concepts. These are Kubernetes concepts. And we map underneath. So as developers, as platform engineers, you work within the Choreo control plane API, Choreo control plane CTL, command line control, command line tool, and we will create the underneath Kubernetes constructs, like namespaces, deployments, and things like that, right? I guess it's clear. So now this is OpenChoreo. This may not reflect exactly how it works in the Choreo SaaS, but now we got some questions during the conference. OK, now you have OpenChoreo. Can I connect my OpenChoreo data plane to Choreo SaaS? That will come up eventually, because you start with OpenChoreo, you download it, you set it up yourself, but then later you want to connect that to SaaS offering. So we can allow that. So this is your data plane, right? And this is OpenChoreo control plane. Now, if you consider Choreo SaaS, it is also a control plane, but managed by WSO2, right? So you could do that. This is like a vision. We haven't implemented this yet. So you will migrate your Choreo projects and component definition to SaaS, and then you can forget about OpenChoreo control plane, right? That's kind of the idea. All right. So as I said, this project we just started OpenChoreo, and we are actively working on it. We want to get to the feature parity as soon as possible. But we need, it's an open source project, so we highly welcome contributions. This is our current GitHub repository. As you can see from the stats, from the commit and everything, it's very early stages. This is the link if you want to try it out. There's a nice quick start guide. You just need Docker and 5-10 minutes of your time. I'll show a screenshot. This command, and it will give you a terminal. You can you can execute some commands, and it will install a Kubernetes kind cluster for you to 1 or 2 nodes. And then it will install Kubernetes on top of Choreo on top of Kubernetes, right? So when you do that, the Choreo control plane, OpenChoreo control plane, comes with certain pods, certain deployments, certain tools. So if you look at this, there's a namespace called Choreo system. And in that namespace, we deploy all our things that we need to make this happen. So by default, we use Argo workflows, Cilium, and things like that, and Envoy gateways, right? So these are all the control plane stuff. And if you notice this one, our controller, this is the custom operator that we have written. We have some CRDs, Kubernetes CRDs, and we have a custom controller to convert them to Kubernetes constructs. All right. Yeah. And then you can use the Choreo CTL to interact with the cluster. You can get components. Everything you can do using the Choreo UI. That features are available via Choreo CTL, right? And then you can do OYAML on that to figure out. Now, next part is a sort of the GitOps way. Basically, all these concepts, basically we made them as YAML, which you can store them in a repository. You can do whatever you like. So this is like the CRD we wrote for a project, right? And there are some custom annotations. We have some documentations around them, so you can find that details. So this is a project. The next one is a component, right? I'm not sure whether you all can see. There's a URL of a GitHub repository. So when we create this component, underneath, we trigger Argo workflow. It will check it out. It'll check it out the code and build it, run test, and push it to a local image. And then it'll create the deployment. Right? It'll deploy to Kubernetes. All right. The next question is, right now what we have is a control plane and a command line interface. But we don't have a UI. We need a portal. I mean, you should be able to see what are the APIs, web apps, libraries, and everything, right? So we have few choices here. The obvious choice would be to build something from Choreo SaaS. We can get the SaaS UI, change stuff here and there, get their modules, and build a UI. But there's another way. We could also use Backstage to build a UI around OpenChoreo. Have you heard about Backstage? Yes? OK. So we could write a Backstage Choreo plugin. And you install Choreo, OpenChoreo. You install Backstage. You install Backstage plugin for Choreo. And then you can visualize everything. And you can also self-service on that. So we have that plan. We haven't actually started, but that's part of the roadmap. All right. Next plan, I guess we need to consider this maybe in Q2 or Q3. When we are ready, when we are at a certain point, we are planning to apply for CNCF sandbox stages, right? So that will give us some boost, so we can blend in with cloud-native community. Right? That's one of the plans, to donate this as a sandbox projects in CNCF. I think we are going in the right direction. If you remember Borg and Kubernetes, right? So Borg is container management, container orchestration system that Google used. I guess they're still using it. And then they decided to open source. But they didn't just open source it. They rewrote everything, taking the best ideas. So that's the plan that we are heading. That's the plan that we are executing these days. So we're not just open sourcing, which is getting the cream of Choreo and converting that to an open source version, right? So as I said, it's at very early stages. So I would like, if you can check out our repo, find ways to contribute, various early stages. What that means is it's easy to contribute. There's not a lot of cognitive load around it. It's early stages. Read documentation. Join our Slack channel. You can report issues. Contribute any way you can.